Hello, this is at THS Mr. Jones, and today we're going to talk about chapter 3.2, which is about graphing functions. So the other day, or if I haven't, I'm going to give you a paper that talks about parent functions. Okay, and there's many parent functions on there. So the ones that you really want to look at are the constant, linear, absolute value, the quadratic, cubic, square root, cube root, exponential, and we won't get into exponential and logarithmic until a little bit later, maybe second semester. Reciprocal, and maybe sine, cosine, tangent at the bottom. Okay, so those are the ones we're really going to work on and then look at, and you should know, like here's that sheet. You should know what each one is, okay, and what the basic parent function looks like. So then we take these parent functions, and then we can rearrange them or transform them into different things, which we'll get to later on. So I first want to talk about the evolution of polynomials. And this will help out a little bit as you see polynomials in graphs. Okay, the first thing we start with is a constant. So we'll say y equals c, y equals x, y equals x squared. And then the fifth. Okay, so for the constant, that's just a y equal, that's a horizontal line. Okay, for y equals x, then we tilt the line. Okay, x squared becomes a parabola. X to the third becomes that. X to the fourth. Okay, I can draw like that, or I'm probably going to draw like this. Okay, x to the fifth. X to the sixth. And x to the seventh. Okay. Now, as you notice, now x to the seventh could look like something like that on the graph. Okay. The actual x to the seventh is very flat. It doesn't have all those mountains of valleys. Okay, so basically what I want you to notice here is as we go up in degree, we go up in the amount of terms that we could possibly have. And notice that x squared, 4, 6, all the even ones, the endpoints are pointing in the same direction. All the odd ones are pointing in opposite directions. And that's something you would have discussed in your Algebra 2 class. So I just wanted to reiterate how that works out. So if I give you like x to the 11th, you should know that no matter what, the ends are pointing in opposite directions. Okay, how do I determine if a function is odd, even, or neither? Okay, so really we're going to talk about odd and even, and then if it's neither one of those, then obviously it's neither. Okay, so an odd function, this is true. F of negative x, so we're plugging in negative x to the function, will give you a negative f of x. So it will be the opposite of the original. Okay, this also has symmetry around or about the origin. Okay, so that's an odd function. You plug in negative x, and you get out the opposite of the function. Kind of like when we did the x, y, and origin symmetries. This is the same type of thing. Okay, so it's got symmetry around the origin. With even function, you're going to plug in negative x, and you will get out the original. Okay, nothing will change. And when we talked about that, we said that that had y-axis symmetry or any vertical line, such as that graph, a parabola. Okay, an example of odd would be something like this. Okay, it has symmetry about this origin right here. Okay, y-axis symmetry or any vertical line symmetry. Okay, so that's odd and even. Again, you will want to know these. Okay, those are really important. Okay, I would write those with a big star, square, highlight them, do whatever. Okay, increasing, decreasing, and constant, super easy. Okay, you're just looking at a graph to determine this. So if I draw a graph here, let's say okay, so increasing, we read the graph left to right, and I'm trying to figure out where is this graph increasing. Okay, let me add some numbers. Okay, well, it's increasing, even though this arrow is pointing down. Since we read it left to right, we know that that is increasing. It has a positive slope, so it is increasing from negative infinity to -2, but also look at -2, it's increasing again. Okay, so it's actually increasing from negative infinity to 2, or sorry, negative infinity to -2, but also -2 to 2. So we could actually write it's increasing from negative infinity to 2. Okay, with a bracket there because I have a closed circle. Now it's decreasing. Well, in fact, this is not decreasing anywhere. We'd have to have a line with a negative slope, something like that, in order to find where it's decreasing. But it is constant at 2 to infinity. Okay, now this one over here, if you want to write it at negative infinity, comma -2, union -2 to 2, you can write it like that. I'm okay with that. If you want to note that they are different, okay, that it may be a restart there. If you want to write it like that, that's fine. Okay, so just look at the graph, see where it's increasing or decreasing. If it has a positive slope, okay, it is increasing. Negative slope would render a decreasing section in your graph. The next thing we want to talk about is the average rate of change. With linear functions, we have a constant rate of change. But with other functions, we have the rate of change is always different. Okay, so we can find what's called the average rate of change. Okay, so if I have, and it's very similar. So if I have this graph here, and let's say I have this curve right here. Okay, I want to find the average rate of change between this point and this point right here, which I'm going to find the slope of the line between those 2 points. And that's actually called a secant line. Okay, and how do I find the slope of the secant line? Well, it's the same as your change of y over change of x. But we no longer have y's, we have function notation. So we're going to say f of x1 minus f of x2, or you can do it the other way around, over x1 minus x2. Okay? And that will find the slope or the average rate of change on a curve at any 2 points. Okay. We have another form to write this. okay, and you did it already, you just didn't know, we have what's called the difference quotient. Okay, now the difference quotient finds the average rate of change as well. So the difference quotient is right there, and h cannot equal 0. Okay? And you know how to evaluate those. You just plug x plus h into the equation, or into f, and then you subtract the whole thing and divide by h and cancel if you can. Okay, now this is a pre-calculus, calculus type topic because it also finds the derivative of functions, which is the equation of your secant line. Okay, but we're just worried about evaluating this and finding the slope of that secant. Okay. And the last thing I want to talk about is a piecewise function. Now, what is a piecewise function? Well, it's just many functions put together. So let's say I have f of x equals, and I could have three equations in here. Let's say x squared, 1, and negative x. So these are three different types of functions in one function. This really should look like that, but that's okay. Now, the most important part about these piecewise functions is where do I evaluate these? And that is given by your domain. So I could say that you're going to use x squared when x is less than negative 1. You're going to use 1 when x is between negative 1 and less than equal to 1. And you're going to use negative x when x is greater than 1. Okay? So you're actually graphing three different things. Okay, if you have your graph here, you're actually graphing three different things, but you're also graphing three different sections. Okay, so I have negative 1 is a section, so I have here is one section that I'm graphing x squared. Between negative 1 and 1 is another section where I'm graphing 1, and then 1 to infinity is my other section. So I'm going to have three different graphs here. Okay, so let's just graph this middle one because it's easiest. I'm just going to graph 1, f of x equals 1 between negative 1 and 1. So I guess I need some more lines here. Okay, so 1. Okay, so you got negative 1, that's a closed circle, and it's a constant. Okay, straight across. So then with this one, this is f of x equals negative x. So that's a line that crosses at 0, 0, and goes down 1, right 1, down 1, right 1. But we don't have points in this window. It is only over here in this window here. So at 1, my graph is at negative 1, but I have an open circle because it said we can't choose it. And we're just going to go down 1, right 1, down 1, right 1, down 1, right 1. And you continue on that path. Okay, we have one more section, which was up here. That's x squared. That's a parabola. So we're at negative 1, 1, open circle. So we actually have a circle on top of the circle. If I plug in negative 2, that's 4. Negative 3, that's 8. So it's kind of off. So we have this part of a parabola there. So that is what a piecewise function is. It is multiple functions separated by domains to form one equation or one graph. Okay, so we're going to spend a little bit of time on those piecewise functions. So your questions for 3.2 are, what does the graph of f of x equals 1 over x look like? Number 2, is f of x equals x to the third minus 1 odd, even, or neither? What is the most important part about graphing a piecewise function? Okay, so those are your 3 questions to have done for class time. And then here are some suggested problems. Not a lot. Here are some true false that may be pretty tricky. I do want to make sure that you really understand what how to graph piecewise functions, because we're going to hit on that quite a bit. Piecewise functions are really, really useful in real life situations, because not everything forms constantly. Okay, so that is all for 3.2. If you have any questions, please let me know. I'll talk to you later.